Hey, everyone. Hey, I've been getting a lot of questions about how to complete the texting and driving unit summative. Now, there are two parts to it. The first part is creating your texting and driving app, which is going to be a spreadsheet, which we're coding. Now, we spent a few days kind of introducing that right before our school closure. And then following that, we're doing a CER. All right. So I'm going to walk you through those two steps briefly. Again, there are a lot of tutorial videos that kind of go with them. So I'm just going to give you the brief overview, and you can watch those tutorial videos for more in-depth instruction. All right, so where you want to start is, again, everything is in Canvas. This is both for the advanced physical science and just regular physical science. All right, we had our texting and driving unit. The main two parts you'll want is the coding for texting and driving summative. Right, this was that one day I was gone. Again, this is kind of the actual spreadsheet app. So if you click here, you guys will find a couple of links to the spreadsheet app. Again, there's a Microsoft Excel version. There's also a Google version, whichever one you prefer. When you open it up, it'll look something like this, right? So for, I think the advanced version is blank slate. For regular physical science, there'll be something here already. In either case, you guys have some tutorial videos over here on the side to kind of help you get started. There's tutorials for each individual step. There's also a little example here for just what it should look like after you set it all up. So for those of you guys who are really struggling, right, when you open up the example, you'll see so I just want to clear this up real quick. All right. So you open up the example, you'll see we already have a format in here. So again, if you just want to save time, you can go ahead, just copy all this, paste it into your blank spreadsheet. Now again, the only thing that this really does is it just gives you kind of just all the text and colored cells, right? There's no formulas or anything. This is just what it should look like before you actually start coding it. So again, if you want to save some time, just feel free to kind of copy and paste that example into your spreadsheet. Now, really, I suggest you guys go ahead and create it from scratch instead of copying and pasting. Kind of a big reason why is that just learning how to kind of set up these spreadsheets is a useful skill. No matter what job you kind of end up in, you're probably going to be doing some sort of work in spreadsheets, even if it's for your own like personal budgeting. So it's helpful just to know how to format, how to kind of play around with it, the different tools. So that's why I would suggest it. Okay. Sorry, quick coffee break. Now you notice we have three columns. We got our input columns, which is going to be colored green, right? This is where we are going to input numbers ourselves. Yellow is where we need some calculations. And then any of these red cells are going to be outputs. So this is where we're going to create a computer code, right? We're teaching the computer what we want. So let's start with our first red cell. We want to find the distance while distracted, right? Because we have our three stages. We have our total distance from car to our pedestrian. And we can break that up into three stages: the distance while distracted, the distance while reacting, and the distance while braking. All right. So we're starting by just figuring out how far do they move while our driver's distracted. Now we know that to find distance while objects move with constant velocity is going to be velocity times time. Now, if I try to tell my computer that I want this red cell to equal velocity times time, it's really not going to know what to do with those letters. Right? So that's not very useful. Right? I'm trying to teach my computer what I want. So what I need to tell the computer is I need to tell the computer where this velocity is coming from. Now, we have a green input cell over here. This is where we're going to actually type in the velocity of our car. So instead of typing in V for velocity, I'm going to just click on this first cell. because this is where we're going to input our velocity, so C4. And we're going to multiply that by the time of distraction, which is this next green cell, C6. You see we get our formula, equal sign C4 times C6. Press enter. You see we end up with 0. But that's okay, right? We want 0. Because right now we have nothing times nothing equals 0. Now you guys will notice when we start inputting some numbers here, we end up with a number right here. Let's go ahead and clear that up. All right, and we know that 20 times 3 is 60. Even though it says 60 here, when we click on it, we can see our original formula right up here. Okay. Now, we figured out our distance while distracted. We moved down to our distance while reacting. Now we know that our velocity has not changed because while you're reacting, you look up, you see the pedestrian, you start moving to press on the brake pedal, but you haven't pressed it yet. So you're still moving with constant velocity. So what we could do is we could just type in 20 meters per second because we know we're still going 20. But one easier way we can do is we can that's annoying. Way to clear up a couple things here. Computer's going a little bit slower than it should. Go ahead and reload this. Save my work, so that'd be annoying. Okay. Luckily, we didn't get too far into this. Okay, there we go. Sorry about that. Three. All right, so like we said, we're still moving with constant velocity. So instead of just typing in 20, I'm going to type in equal sign, whatever this initial velocity is. I see I'm getting the wrong number there. That's in part because I clicked on the same cell twice. All right, so now notice for the distance while reacting, for the velocity of the car, I just wrote in equals C4, right? So whenever I change this number should change as well. So all I have to do to change the velocity is just change this first cell and it will update here. All right, time of reaction, right? I can figure out just what's the reaction time of my driver. I can just input this. Remember, reaction times tend to be pretty quick, right? So I would say definitely under a second, unless the person is really struggling to react. Again, same thing, right? Still move with constant velocity, still going to have a similar formula. So we're just going to do equal sign, whatever our velocity is, multiplied by the time. As I change our reaction time, right, it's going to change how far we move in that time. Once again, we get to our last section, distance while braking. And here, again, our velocity of the car before we start braking, still going to be the same. I'm just going to say equals C4. So notice when I change this first velocity, I update here, for distance while reacting, it's also going to update here. Velocity of car after braking. Now, you guys should be able to figure this out. When you've come to a complete stop, how fast are you going? Should be 0. All right. Deceleration of braking. Again, this is a number you guys can type in. Just notice it's deceleration, so you're slowing down, so it should be a negative number. All right, figure out time of braking. Now this you need to, again, put in a formula to figure out time. So, and this is while accelerating. So the formula we learned for acceleration is acceleration equals final velocity minus initial velocity divided by time. Now in this case, we want to get time by itself. So what we would do, right, just using some algebra to get time by itself, is we'd multiply both sides by time. What we'd end up with is acceleration times time equals final velocity minus initial velocity. Again, to get time by itself, we then want to get rid of the acceleration. So divide that side by acceleration, divide this side by acceleration, to leave us with time equals final velocity minus initial velocity, all divided by time. And that is the formula that we want to teach our computer. So time equals our final velocity, which we get from this cell, minus our initial velocity, which we get from this cell, divided by our acceleration, in this case, deceleration. Okay, and then one thing you can do too, to just kind of make sure that this is calculating correctly, is we can add some parentheses here, just to make sure that it is doing it properly, which it should by default. Right? Notice before and after we put the parentheses, our number did not change. Okay, last thing we need to calculate is just our distance while braking. Now we learned in class that our distance formula is the initial velocity times time plus 1/2 acceleration multiplied by time squared. So again, this is the formula that we are teaching our computer. So that means we have equal multiplied by time so multiplied by time plus 0.5, which is 1/2, multiplied by acceleration multiplied by time squared. Okay. Now our total distance our car travels is going to be, right, our distance while distracted plus our distance while reacting plus our distance while braking. So it's all three of our red cells add up together. So we're going to do equal sign, the distance while distracted, plus the distance while reacting, plus the distance while braking. And we get our total distance. Now, we want to figure out how far was the distance to the actual walker, right? So at the very beginning of the system, how far was it from the car to our pedestrian? And this is just a number that we can input ourselves. Let's say 40. Now, if we want to find the total, like the outcome of our system, right? Was our pedestrian hit or not? We can set up a little formula here, right? And what we're going to do is we just want to do equal sign if, I'm going to do a little if then statement. So if our total distance the car travels is greater than our distance to the walker, we want to create a couple statements. So we're going to add some parentheses. So if the distance is greater, we can say something like call 911. There has been an accident. And then if the total distance car travel is less than distance to walker, we say, please be more careful, or something like that, right? Just indicating that there was no collision. All right, so now you notice here, right, if our total distance car travels is greater than distance to walker, we get just a statement, call 911, there's been an accident. Now, if we increase this distance, let's say distance to walker is greater than the total distance traveled, we get a statement here, please be more careful, right? So depending on the numbers we get, right, say if we were going even faster, increase the velocity, notice our total distance has increased by a lot, notice our statement changes. All right, so from here, you guys will have, if you follow these steps, you should have a completed app. It should be working. Again, if you need more step-by-step instructions, please see these tutorial videos. You guys will need your app to do part 2 of the summative, and this is writing your CER. Okay, sorry, the video is just being glitchy. All right, so we are going back to Canvas. Okay. Finding our texting driving unit summative. So this is the CER portion. All right, now remember, CER just stands for claim, evidence, reasoning. And we're just answering the statement, which is better, distracted or alert driving? All right, just create a claim for that. And you can access the assignment using one of these links, right? There's Microsoft Word version, Google version. You guys open it up. It looks something like this. Get our question, which is better, distracted or alert driving? We have a video tutorial on how to go through this claim, evidence, reasoning. Plenty of sentence starters to kind of help you guys out. But main thing that we're doing is, again, we're just writing a 1-paragraph statement about the system, right? So write a sentence stating if texting driving is potentially hazardous. Now, one way you do this is I'm giving you guys some numbers to put into your app. So I'm saying if your initial velocity is 15 meters per second, right? So we're making our velocity 15 meters per second. The reaction time is 0.5 seconds. The acceleration is -8, and the distraction time is 3 seconds, right? So if we put in all that time, okay, distraction time 3 seconds, time reaction 0.5, and deceleration is -8. Right, we're trying to determine if texting driving is potentially hazardous. So we entered all those numbers in. Again, you can kind of determine if those numbers produce a total distance traveled that is dangerous, right? You want to think about in a realistic scenario, like think if you're driving in the parking lot of the school, how far might a pedestrian be away from you realistically, you know? And here we're getting a total of 66 meters. That might be way too far, right? So your claim is just writing a 1-sentence statement about whether or not it's potentially hazardous. Evidence, take a screenshot of your app, of your spreadsheet, and insert it here as your evidence, right? Use some sentence starters to kind of communicate your evidence for this claim. And then reasoning, right? Write a statement that explains how your evidence led to your claim about if texting driving is potentially hazardous. So just one quick, pretty simple CER using just a screenshot of your app. Second part here is just same thing. This time we're just kind of changing some of the numbers up, right? So just assuming that, the conditions are icy. So how's that going to affect your deceleration? So same thing, write your claim, take a screenshot of your spreadsheet, and then write your reasoning statement. Again, hopefully that helps. There are plenty of other YouTube tutorials that are already in these assignments to kind of help you out. I'll post this in Canvas and kind of send this out as a link to all of you guys. If you have any questions, feel free to email me, and I'll talk to you guys soon.